So now we're going to be looking at the epsilon-delta definition of a limit. Now, this is not covered in AP Calculus, but it is covered by some professors and some teachers when they want you to know the rigorous definition of limits, the epsilon-delta definition. Okay, and the way you do these proofs is a little bit tricky and a little bit strange, but let's talk about it. The first concept is that what you're trying to find is you're trying to find both epsilon and delta. You're trying to say for an arbitrary epsilon, can I find a delta to where when the y value of the function differs by epsilon, that the x value differs by some delta. Okay, so I can find a delta for every epsilon. So for linear functions like this is pretty straightforward. So let's look at this. Limit as x approaches 4 of 2x plus 5. If I plugged in x equals 4, I would get 13. And what I simply start with is I say, well, 2x plus 5 minus 13. The difference between the function and the y value, the absolute value, is less than epsilon. And I'm trying to find what delta is equal to. And delta ought to be a function of epsilon that gets smaller and smaller too. So then we have absolute value of 2x minus 8 is less than epsilon. I can factor out a 2, and x minus 4 is less than epsilon. And so then I get x minus 4 is less than 1/2 epsilon, and that's equal to my delta here. And now you see, I found that for an arbitrary epsilon, when the y value differs from this 13, the x value differs by 4 by this delta. And that completes the proof. Okay. So here I have another linear function. It's kind of the same idea. I'm going to start with x minus 3. This function minus this value here, the value of the limit, is less than epsilon. And I'm trying to find what delta is. Well, this becomes x minus 2 is less than epsilon. And that's what I wanted. I want the x value to be approaching 2. So I want the difference from x to be 2 to be less than some delta. In this case, epsilon would equal my delta. Okay. Now, we can't always do this. Sometimes it's really hard to determine what the delta is from just the epsilon. Like if I started, same here, x squared plus 1 minus 2, the difference in the y value is less than epsilon. It's actually analytically hard to maybe figure out what the delta ought to be. You could do it, but sometimes what we start with is to say, well, I know that x minus 1 ought to be less than delta, and I want to find a delta that can make this work, a delta equal to some epsilon here. So this equation, what I get is the absolute value of x squared minus 1 is less than epsilon, and then I can factor this into x plus 1, x minus 1, absolute value. Now, I know that this is equal to, I can break up this absolute value. It would be the absolute value of x plus 1 times the absolute value of x minus 1. But I know that x minus 1 ought to be smaller than some delta, right? So I know that if delta is bigger than this quantity, then this thing has to be smaller than x plus 1 times delta. Okay. Now, this x plus 1, I have to think about. So one of the things you usually want to do is you want to say delta is pretty small, usually in these examples, because we want as the y value is getting closer. So I could say, for example, say x minus 1 absolute value was just less than 1. Okay, say delta was less than 1. Okay, and that's a fair assumption because it's okay, because we're always talking about as we get closer and closer, like when epsilon and delta are getting closer to 0. That's what's usually happening. So let's say that this is true. That means the absolute value of x would have to be less than 2. And that means x plus 1, the biggest it could possibly be is 3. Right? Because if x minus 1 is less than 1, that means x could be at most 2. And that means x plus 1 could be at most 3. So that this quantity would be smaller than 3 times delta. And that's equal to my epsilon, because what I wanted to was here x squared minus 1 is less than epsilon, but I've already demonstrated that it's less than 3 delta. And if I set that equal to my epsilon, then delta just equals 1/3 epsilon. Okay. So again, I found for an arbitrary small epsilon, I have found a corresponding delta that I know that x is within. So if I pick an epsilon, I know that delta is within 1/3 of epsilon. If the y value differs from 2 by epsilon, the x value is going to differ by 1/3 of epsilon, at least. You could have used different values here. Like you could have said like Like, this isn't unique. As long as I find a value of delta with a corresponding epsilon, I've completed my proof. Okay. Let's do it. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.